So now, here we have a 555 timer. We're not using the timing though. We're just going to make it in bistable mode. That's what we got wired up. So output is high right there. It's going to stay high until we press the button, giving a low signal to the reset pin. Now it's low, it's going to stay low. That's why it's bistable. It'll stay in either state. Until now we give a low input to the trigger pin right there. One thing to be aware of though is that the reset pin is more powerful than the trigger pin right there. So now here's a quick look at the schematic for the 555 timer wired in bistable mode. We disabled pin 6, a low signal to pin 4, sets the output low there, and I used a blue LED. It lights up really well, makes a really good connection to ground. Low input signal though to the trigger pin, pin 2 right there, sets the output high. You do lose some voltage through the transistors though, so probably about a volt is lost. I used a red LED to indicate when the output's high. So now, for those of you newer to these circuits, I'm using a blue LED there, and as you can see we have this path where it will light up when the output is connected to ground, and I used a blue LED. We'll look at that closer. Whereas you have a red LED right there, and of course that side's connected to ground, and so when the output is high, connected to the positive supply as good as it can do, then that one will light up. So we'll come over here, and there you can see the blue LED coming to the positive supply. That's the long lead, the anode. Make sure you put it the right way. Short lead, the cathode, coming to that 1000 ohm resistor because it's pretty bright. We don't need a lot of current. Going to the output. Now we have at the output the 220 ohm resistor going up to the long lead of the red LED, short lead, the cathode there, going to ground, so that it lights up when the output, of course, is connected to the positive supply, as good as it can be. So now, of course, we have to power the integrated circuit, but we're going to look at the inputs. Pin 6 there, we put to ground, that disconnects it. A high input sets the output low, but we're not going to use that in this case. Instead, we're going to give a low input to pin 4 to set the output low. And we have a 10K resistor. That's a pull-up resistor. That's so stray signals don't come in and falsely trigger it. We give it 5 volts till we press the button. Same thing with pin 4 there, or pin 2 I mean, the trigger pin. We have a pull-up resistor to prevent stray signals until we press the button. Then we get a direct connection to ground. But there you can see the switches right there. And there's our pull-up resistors. They're coming to where the output is, direct connection. And when you close the switch, then it makes that connection to ground. Pretty simple right there.